All right, let's just jump right into a wild idea. What if I told you that our bodies might have a hidden backup system for breathing? Yeah, it sounds like something straight out of science fiction, right? But today, we're going to explore a very real and honestly, a very surprising scientific question. When our lungs are failing, could we actually breathe through our guts?
So, here's how we're going to break it all down. First, we'll load up our biology toolkit with a few key terms so we're all on the same page. Then we'll get into the really moving personal story that kicked this whole thing off. After that, we'll dive into the butt-breathing hypothesis itself, see how they took it from animals to humans, and finally, we'll ask the big question, is this really a breath of fresh air for medicine?
Okay, before we get into the absolutely fascinating story behind this experiment, we need to make sure we're all speaking the same language. So let's quickly stock up our biology toolkit.
First up is pneumonia. You've probably heard of it, but it's a really serious infection that basically inflames the air sacs in your lungs. It makes every single breath a struggle. And you know what? This exact condition is what gets our whole story started today.
Now, when someone's lungs are failing because of something like pneumonia, they might be put on a ventilator. This is a life-saving machine that, literally breathes for you. But as we're about to find out, it's what doctors call an invasive procedure. And just seeing one in action can be a huge motivation to find another way.
This next one is absolutely central to the experiments we're going to talk about. Hypoxia. That's the dangerous medical term for when your body, or even just a part of your body, is being starved of oxygen. The entire goal of this research was to find a totally new way to fight off hypoxia. So if you can't use the lungs, where do you go? Well, the researchers looked right here, the intestinal tract, or what we usually just call the gut. Think of it as this long, winding tube that's just packed with blood vessels. And that fact, that it's so rich in blood vessels, that's a really important clue. And here it is, the star of the show, perfluorodecolin. It's a special kind of liquid that has this amazing superpower. It can absorb and carry huge amounts of oxygen. So the most important thing to remember is that this liquid basically acts like a tiny delivery truck, designed to carry its precious cargo of oxygen into the body through a completely new route.
All right, now that we've got our vocabulary down, let's get to the heart of it. This radical idea didn't just pop up in a lab. It actually came from a deeply personal family experience.
This is what Dr. Takanori Takebe said after he saw his own father, who was really sick with pneumonia, get put on a ventilator. That moment, seeing just how invasive and difficult that whole procedure was for his dad, it sparked a question in his mind. There has to be another way to get oxygen into the body, right? So this personal crisis led Dr. Takebe, who's a specialist in the digestive system, not the lungs, to a pretty unconventional idea. An idea he got from, of all things, freshwater fish.
See, Dr. Takebe knew that some fish can actually pull oxygen from the water through their guts when oxygen levels are low. And he connected that to something we already know from human medicine. The gut is so full of blood vessels that an enema can deliver medicine straight into your bloodstream. So he thought, wait a minute, if the gut can absorb medicine, maybe, just maybe, it could absorb oxygen too. The plan they came up with was actually brilliantly simple when you look at it. They take that special liquid, load it up with oxygen, deliver it, well, like an enema, and then just hope that the oxygen would pass through the intestinal wall and right into the bloodstream. It's a really bold plan, but would it actually work?
The theory sounded good, but they needed proof. So the big test came when they did experiments with pigs that they had put into respiratory failure. And the answer to whether it was working or not would be literally written in the color of their blood.
So before the treatment, the researchers drew blood from these oxygen-deprived pigs. And just like you'd think, it was this dark, muddy, really unhealthy color. I mean, this is blood that is just starving for oxygen. But then, after they administered the oxygen-filled liquid, they drew blood again. And wow, this was Dr. Takebe's big aha moment. The blood was now a brilliant, healthy, oxygen-rich red. This picture just perfectly shows their success. They were getting oxygen into the bloodstream, and they were doing it by completely bypassing the lungs.
Okay, so after that incredible proof of concept in animals, the next and much, much bigger question was, could this ever be done safely in people?
This table lays out their journey perfectly. First, the trials in mice and pigs proved the method was effective. It helped them survive. Then they moved on to healthy male volunteers. But here, the goal was totally different. It wasn't about effectiveness. It was all about safety. And the results showed that most of them could handle up to 1 liter of the liquid with only mild side effects, like some bloating. This was a huge, crucial step forward.
This work even got a bit of a cheeky award, an Ig Nobel Prize. And these awards are for science that, quote, makes people laugh and then think. Which, let's be honest, is a perfect way to describe research some people call butt breathing, but is actually trying to solve a deadly serious problem.
But, like with any truly new idea, not everyone in the scientific world was convinced. Success in the lab doesn't always mean success in the real world, and some pretty serious questions were still floating around. And this really brings us to the biggest question of them all. Yeah, okay, it gets some oxygen into the blood, but could it ever deliver enough oxygen to make a real difference for a human patient who's in critical condition?
So here's the skeptic's point of view, from Dr. John Laffey, who's an expert in respiratory failure. His argument is pretty simple. Our lungs are designed for one job, and they do that job incredibly well. Even when they're damaged, they are just way more efficient at getting oxygen than the gut could ever hope to be. He thinks we should be focused on fixing the lungs, not trying to find a way around them.
And Dr. Laffey, well, he's got the math to back it up. So get this, a full liter of that special liquid can carry about 500 milliliters of oxygen. But a person who's just resting uses about 250 milliliters of oxygen every single minute. You do the quick math, and you see that one dose would only give you about 2 minutes of oxygen. And that makes it really hard to see how this could provide any kind of long-term support.
And that's a very strong point. But other doctors aren't quite ready to dismiss the idea. They see its potential not as a replacement for a ventilator, but as a kind of short-term bridge in critical emergencies. I mean, imagine using this to give a patient a quick oxygen boost during a really risky surgery, or as a stopgap measure in an ambulance on the way to the hospital. In those moments, an extra 2 minutes of oxygen could literally be the difference between life and death.
So, while this idea of enteric oxygenation might not replace our lungs anytime soon, this research really does crack open a fascinating new door in medicine. It makes us rethink the hidden potential of our own bodies, and it leaves us with this final, really thought-provoking question. Could our gut, maybe in some small but truly life-saving way, one day really serve as a backup for our lungs?